6-week course. I can't do much about that. Where am I here? Okay. Oh, there we go. Let's do that. All right. Okay, chapter 11 is hydrocarbons. Chapter 10 was hydrocarbons, but they were saturated. Chapter 11 is hydrocarbons, and they are unsaturated. So what does that all mean? Alkenes, alkynes, and aromatics. So if I talk about alkenes, I need an L in there. Alkenes, their prefix is going to be ene, and we're talking about a carbon-carbon double bond. Alkynes, the world is made up of all alkynes, made up of all kinds, alkynes. Ines, carbon-carbon triple bonds. These are both unsaturated. If a molecule only needs one of these in it to be unsaturated, doesn't have to be, not like alkanes where they're all saturated. You put one of these bonds in an alkane, and it's not an alkane anymore. It's an alkene or an alkyne. Both alkenes and alkynes are unsaturated. The alkene functional group is a carbon-carbon double bond. Alkynes are carbon-carbon triple bond. Simplest alkene is C2H4. It doesn't start with one carbon. You can't double bond carbon to itself. So ethene is the smallest alkene. That is its IUPAC name. And this is its common name. Anybody ever heard of polyethylene? No? Polyethylene? Those are Ziploc baggies. They're made, that's polyethylene. So ethine is the smallest alkyne. Okay, this slide's kind of good because it shows you a 2-carbon alkane, ethane, 2-carbon alkene, ethene, a 2-carbon alkyne, ethine. And what you got the structural formula right here. You've got the molecular formula right here. You got a condensed formula right here. When we write it into a condensed formula, we will put in the double bonds like that. When an alkane, we didn't put any bonds in there, we will actually slip the double bond in to a condensed formula. I don't know how you do that on Word. I mean, you could put an equal sign, but I don't know how you get the triple bond. Anybody know how to get that kind of 3 lines in a row? I must have never typed an alkyne. All right, the models you can see right there. Okay, this is interesting because what it shows you here is that we've got 120-degree bond angles here. Around the double bond. You can see that we only need to go a third, another third, another third. We're completely in a circle, and a circle has 360 degrees. So we don't have tetrahedral bond angles. I really should have brought this model. I probably could put one together pretty fast. It's a flat molecule. See if I got a double bond. what you notice right away, when I say it's a flat molecule, there's 2 carbons, 4 hydrogens, they're all in a plane. All 6 of those nuclei, those atoms are in the same plane. So it's flat, and then you go 120, 120, 120, 120 degree bond angles. And then the ethine, what kind of bond angles do we have here? Well, boy, that's half a circle, and there's the other half a circle. So these are 180 degree bond angles. And those 4 atoms are in a line. Right? This model is mimicking, these models are built around the X-ray diffraction of these compounds and where the atoms are relative to one another. So that's all right in a straight line. So keep that in mind as we start drawing things and the way we convert this into line diagrams and things like that. It'll help you. All right, so let's take a look at this one right here. This is a new battery. I was just writing a second ago. I didn't want to write. The first couple weeks I had this computer, and this pencil, I just kind of played with it like this, and it stopped writing, and actually went over to the Microsoft store and said, pen doesn't write. The guy tightened it, started writing. He said, there's a battery in there, sir. There's a battery in there. Oh, is that right? Yeah. He says, you got to have good contacts. So, there we go. Must have warmed it up or something. Okay, I wanted to circle that. Look at that, I think. And so you got it right there, but sometimes it's kind of neat to just really see it in real life. So let's take 3 carbons and put them on this thing. And there's our molecule. Now you might, or the automobile industry might say, well, boy, you got a hybrid there. That's part alkane and part alkene. Well, this is an alkene, and it's 5 carbons, 1, 2, 3, 4, 5. So what's 5? Pentene. This is pentene. It's got 1 double bond. But it is a hybrid in the sense of bond angles. There's 120 degree bond angles around this part here, around the double bond, and then we come on over to here, and we're back to pentane, or we're back to an alkane saturated carbons that have tetrahedral bond angles. That all makes sense? Was there something else on that slide I was supposed to say? Yeah, okay. Yeah, we'll get into line diagrams, but so they're just, you got pentane on the left here. Is that on your left? Yeah, on your left. Pentane is a basic zigzag structure you learned in chapter 10. We got pentene, and we're going to have the zigzag structure on that part of it, and then the alkene there, and then pentyne. I crossed over in here, but see, that's 1 pentyne. We'll get into this, but if we got 5 carbons here and a triple bond in it, you need to tell me where that triple bond starts. Starts on the first carbon. Could be right here. Could be. There's 2-pentyne. That's another. So what you're doing now is what we are doing, we're transferring what we learned in chapter 10 about alkanes and the IUPAC naming system, and we're picking all that knowledge up and moving on into chapter 11. What's going to be applicable? IUPAC rules. Find the longest chain. The 6 substituents you learned in chapter 10. They're going to be handled the same way in chapter 11. If there's a methyl group, we're going to call it a methyl group. If there's an isopropyl group, it's going to be an isopropyl group. We're going to find the longest chain. If it has a double bond, we're going to change it from ane to ene. If it has a triple bond, from ane to ine. All right? So that's why you really have to establish the good foundation in chapter 10 about what we're doing. All right, I told you in chapter 10 that alkanes are nonpolar. These alkenes are nonpolar. They're not soluble in water. They are soluble in other nonpolar things like alkanes. So alkanes are soluble in alkenes and alkynes are soluble in alkenes and alkanes because they're all nonpolar. This just shows some of that. Here's some different molecules. Some of this I'm going to slide through pretty quickly. Okay, IUPAC names. So ethane, propane, we got ethene, propene, ethyne, propine. Now propene and propine, and neither one of those needs a number in the name because there's really not too many other places. I mean, if you imagine me writing that way, that's the same as that molecule above it. I could pick that up, turn it over, and it'd be superimposable on each other. So there's only one propene. There's not a 1 and 2 propene. There's just one. Same way with propine. IUPAC names. Number from the end that will give the first carbon of the multiple bond the lower number. Prefix the name with the number of the first multiple bond carbon. Example. Okay. Okay, rule number 1, find the longest chain. Do the top one. Let's do the top one, the one with the double bond in it. Let's not try to do them both at the same time. Let's do one at a time. What's the longest chain? How many? 7? 7. Okay. Everybody see at least 7? So, okay, now here's one little thing here. Since we're going to call this heptene, ene's a double bond. Let's see if the rule said that back here. Yeah, this rule right here. Number from the end that will give you the first carbon of the multiple bond, the lower number. So we're not looking for the first substituent on this long chain. Since it's going to be called heptene, and ENE is actually in the name, we're going to look for the first double bond. We're going to look for, not the first double bond, we're going to look for the end of this 7-chain carbon chain that is closest to that double bond, where that double bond starts, okay? Everybody with me on that? So for example, let me just tell you this. Here's number 1, 2, I don't know if I can, can I get a 3 in there? I can hardly see it. So this is carbon number 3, 4, 5, 6, 7. Why? Because if I started at this end, I'd be 1, 2, 3, 4. Yeah, if I started at this end, I'd have 1, 2, 3, 4 before I get to the start of that double bond. If I start up here, it's 1, 2, 3. I don't care. You can start here. 1, 2, 3. Either way, you got this left over and that left over. Okay? But we now know what carbon they're on. What is this thing right here? It's an ethyl group. All right, see, this is what you learned in chapter 10. What is that thing? It's a methyl group. And that methyl group is on 6. This ethyl group is on what carbon? 3. That's a 3 ethyl. So let me erase this 6 down here and this 7. That's my phone. Sorry, I didn't turn it off. Forgot to turn that off. Okay, so we already figured out that this is called heptene. Now, we need this number, 3. Heptene. That number is telling us where that double bond begins. It begins on the 3rd carbon. You don't need both numbers. You don't need to say 3, 4, heptene. Just say the number of the carbon where the double bond begins. Begins on carbon number 3. Where does it end? Carbon number 4. It's a double bond between 2 carbons. So if it starts on 3, it has to end on 4. Okay? So you don't need to tell me that. You see, chemists, they like to save ink. They're conservationists. They like to save ink. So we're going to put a dash around both of those. All right, so now let me finish it off. We left out the ethyl, we left out the methyl. So which one goes first? Ethyl. 6 methyl. 3 heptene. That's the name of that molecule. You see, we pretty much used everything from chapter 10 with a little bit of a tweak. We now need to say where, see this 3 here relates to this functional group there. That's why it's right in front of the parent name. Ene says there's a double bond in here, and you need to specify where it is. All right, let's do the one below here. What's the longest chain? 6. So 6 is hex. Right, and it's got a triple bond in it, so it's hex-ine. All right, now, where does the triple bond begin? On 3. Now, this is a tricky molecule because that triple bond is right in the middle of the molecule. Notice I could say 1, 2, 3. Oh, it starts on number 3. I could say 1, 2, 3. Oh, it starts on number 3. Doesn't matter whether I aim it here or there. But we've got this right here. So this isn't going, just like up there, just because we got to it on the 2nd carbon, we didn't call that number 1. We called this number 1 because it got us there faster. But down here, since it's 3, whether I go from here to there, or from here to there, I'm going to call that number 1, 2, 3, because that's going to give that a lower number. Okay? So there is a real carbon number 1 here, and that's it. And that's 2, and that's 3, and that's 4, 5, and 6. So what's the rest of the name? Boy, you guys are so good, I tell you. I need to meet your teacher. All right? 2-bromohexane. That's the name of that molecule.
Do we need to put the 3 in there?
Oh, sorry. Oh, definitely. 2-bromo. Yeah, please don't let me just swing by something like that. That would have been a terrible error. 2-bromo-3-hexane. Yes, you need the 3. Just like we needed the 3 up there with the alkene. All right? You getting it? There you go. I didn't know I had the names on the next slide. Need to get that slide out of there. What is its name? Okay, so see if you got it. Try to figure this one out. Okay, this has got a little trickiness in it. Okay, before you go too far, who thinks the longest chain is 6 carbons? Who thinks the longest chain is 7 carbons? Okay, see, there's the trickiness here. Here's the problem. And I can see, you say the longest chain, so I'm not going to write on that slide right now. 1, 2, 3, 4, 5, 6, 7. That's a long chain, right? Now, there's a problem with that. What's the problem with that? It doesn't include the double bond. That chain doesn't include the double bond. It has it hanging off the side as a substituent. We're not going to handle a double bond as a substituent. So you must find the longest chain that includes the double or triple bond. So you can't kind of go up here to include it. We got to start here. 1, 2, 3, 4, 5, 6. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those aren't long enough. So 1, 2, 3, 4, 5, 6. That's your longest chain. Which means this is a substituent. This is a substituent, and this is a substituent, and what's left over there is the longest chain. All right, so that's a tricky molecule. It won't be for you anymore, but you just have to know you're not just hunting for the longest chain, it's got to include the double bond. So what's the parent name of this? Hexene. And where does the double bond begin? On the very first carbon. This is carbon number 1, 2, 3, 4, 5, 6. So what is that on carbon number 2? And then what do we have on carbon number 4? Okay, so we're going to have 4, 4 dimethyl. Now you can see why we need these, and I'm sorry I can't write as beautifully with this pen as I might on a sheet of paper. But this is a 1, and that's an L at the end of methyl. So you need a dash between that L and that 1, and then another dash. side of it. That's why we need to really segregate our numbers from our letters in the name. Any question about that one? Okay, as soon as you get something under your belt, we make it more complicated. Here's a molecule with two double bonds in it. Hexa, two double bonds. We got a double bond. Ene. What do we do with methyls? We say dimethyl. Well, we're going to say diene. 2,4-hexadiene. This one starts on carbon number 2, 3, 4. Another one starts on carbon number 4, so it's 2, 4-hexadiene. You can come back and digest that. You won't see a lot of these. You might see hexadiene pop up somewhere. Naming cycloalkenes. Naming cycloalkenes. So you've already been introduced to this cyclohexane. Before we look above there, let's just look at a simple one. There's cyclohexene. This is not an aromatic molecule. We haven't gotten to those yet. We're going to try to today, but this is just an alkene that is in a ring. Cyclohexene, and it has one double bond in it. 6 carbons. Okay, now let's get a little bit complicated. I'm going to go up to the original slide here, and what do we have? We've got a ring like that, but we got some things on it. So what we're looking at is, if we were looking at a line diagram, we'd be looking at something like this. All right, there's a line diagram of it. So this brings up a question. Okay, what's carbon number 1? Is this carbon number 1, or is this carbon number 1? Where do I start counting? Yeah, well, let's take a look. If I start there, I'm starting at this one here. So 1, 2, 3, 4, 5, 6. So this one down here would be number 6. 1, 2, 3, 4, 5. Yeah, let's look at that. If I started here, I was saying, well, let me see what happens if I start here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah. So if I start here, you can see 1, 2, 3. I get to the chloro group on number 3. 4. I get to the methyl group on number 5. So there's going to be 3 chloro, 5 methyl, cyclohexene. So if I start here, I get to the methyl as 2. 3. I get to the chloro as 4, and those are lower numbers. 2 and 4 is lower than 3 and 5. So you want to start counting. Oh, wait a minute here. 1, 2, 3, 4, 5. Yeah. You got to pass through the double bond. Yeah, you have to pass through the double bond. So I do have to start here, but I need to go in that direction. 1, 2, so that's 1. Let me clean this up a little bit. 1, 2, right. You got to pass through the double bond. Yes. 4, 5, 6. So yeah, what we'll get there is a 3, 5. And if I started with number 2, if I started here, I have to pass through the double line. So 1, 2, 3, 4, 5, 6. I don't get over that till 6.
I have a question. I know you said you have to pass through, but I thought with the naming rules, when it comes to like a substituent, I thought you have to name the chlorine.
Well, I think what's going to take precedent and get the lowest numbers for all the substituents on it. All right, so 1, 2, 3. Yeah, so if we start here with that as 1. Yeah, numbering must start at one end of the double bond and pass through the bond. Substituents must have the lower possible numbers. Sylvia, that would probably come into play. It could come into play in a situation where if you went one way, you got to the methyl on the number 3. You went another way, you got to the chloro on number 3, and you'd give precedence to the chloro. Okay, if there was a situation where, yeah. I gave an example in chapter 10 where I said there were 2 possibilities there, but both would be acceptable. Where are we here? All right, so 1, 2, 3, 4, 5. 3 and 5 is 8. 4 and 6 is 10. So we're going to not go that way. We're going to go with the one that gets us the lowest combined numbers. Here's examples with halogens on them. We've already had this one with the 2-bromo-3-hexyne. Yeah, Sylvia, here, I think this one is getting at what you're saying right there. See, here's a situation where we got a chlorine here, we got a methyl here. So it could be 1, 2, 3 methyl, 4 chloro. It could be 1, 2, 3 chloro, 4 methyl. And we're giving precedence to the chloro.
So what if you would change that to like a cycle? Then would the naming still be the same? Because the other one you didn't do it that way, that's why I'm confused.
Well, okay, well, look at if this were 3 plus 4 is 7. If I went with 4 chloro, 3 methyl, 3 plus 4 is 7. So it's a dead heat. Okay, there's no, the total number for all the substituents is 7, whichever way we do it, but now we're going to prioritize the chloro. All right, think about it. And the other one,
I get what you're saying, because my question was if you were to change that molecule right there, the entire strand, to a cyclo, it would still be 3 chloro 4 methyl 3 or cyclohexene.
yeah, you're saying we cyclize this thing right here?
Yeah.
Yeah, we won't do it right now, but if you want to put that into a cyclical thing, yeah, you'd give precedence to the chloro.
Okay, no worries. I'm not gonna hold it.
Okay, now the water gets a little bit deeper. Here we are going to get into geometric isomers. What do we mean by that? And our poster child for that is going to be butene, 2-butene. Butene. Why is that? So let's think about 2-butene for a second. So I could have, and I'll draw the structural diagram. There's my double bond. There's my 4 carbons. And if I look at this, carbon here, it has 1, 2, 3 bonds around it. So what do I need to put here? What? A hydrogen. And this needs a hydrogen. This is also 2-butene. And what you have to understand about this is, remember I made the point in chapter 10 that we could rotate around a single bond. And I said that won't make a whole lot of sense to you, or what's the difference until we get to a double bond, because this doesn't rotate. The pi bond, what we call a pi bond like this, fixes those carbons. They can't rotate like this. So these 4 things coming out around the double bond, I mean, this is what a double bond looks like. A double bond looks like this. It's got 4 things coming out around it. They are really in a fixed position, or they happen to be. So this molecule I have right here is this one. It's still 2-butene. This molecule over here, in order to get that into that configuration, I've got to actually rip it off and put it up there. I can't rotate it up to that position. That's that molecule. So we have to distinguish these, what are geometric. It's just the geometrical shape of the molecule that is fixed. So I'm going to get this out of here. So this is 2-butene. This is 2-butene. How are we going to distinguish them? Well, we're going to call this cis 2-butene. And the one on the right here, we're going to call trans 2-butene. These are cis and trans isomers. Trans meaning they're across these 2 methyl groups here, or these 2 hydrogens, whichever one you want to think of them, are across from each other. You make a call from New York to London, it's a transatlantic call. I don't know if we call it an international call, but when I was your age, the only way you did that is this huge cable that went underneath the ocean and went off to London. That's how you did this. That's how you made a call from New York on a oceanic cable that was under the ocean, 4,000 miles long, went from New York to London. And then we came up with satellites and cell towers and ching and bingo, and anybody wants the cable, they'll sell it to you for $50 if you want to get it all back, if it's still there. Okay, so it was a transatlantic call, and so that's the trans isomer of 2-butene, and this cis, or same side as on the same side of the double bond, cis 2-butene. Cis and trans isomers. There it is, drawn a whole lot nicer than I did, but there it is. All right, so there's certain conditions under which you are talking about cis and trans isomers, and there's certain conditions under which it's not necessary. They really are not two different isomers. So let's try to figure that out. What are the ways of identifying it? Well, you're going to focus on the two carbons that have the double bond, and you're going to look at the things that are on those two carbons, and you're going to ask 3 questions. And you basically have to get yes answers to all 3 questions. If you can answer yes to all 3 questions, then you do have cis and trans isomers. So you can see here we have, here's our double bond. So ignoring that, we're looking at the 4 things that are on that double bond. We're going to look at the first carbon, and ask the question, are both groups that are on that carbon the same? Or are there 2 different things on that carbon? And the answer is yes. Then we're going to go over to this carbon. Are the 2 things on this carbon different? Yes. Got 2 yeses. And then the third question is, do each of these carbons have something on them that is the same? Yes. They each have a methyl group. So bingo, we got 3 yeses. Does carbon have 2 different things? Yes. Does that carbon have 2 different things on it? Yes. This is not the same as that. And do these 2 carbons each have something that's the same? Yes. So there would be a pair of isomers. This would be one of them. But if you can imagine, if I move this down to here, see, this is on the same. The 2 things that are on the same, 2 things that are the same are on the same side of the double bond. So this would be the cis isomer. And if I move this down to here, move that hydrogen up to there, that would be the trans isomer. We're only looking at one of the isomers right here. But we've got 3 yes answers, so there we're saying, there is a geometric isomer to this molecule. And so, how are we going to name it? Well, longest chain, 1, 2, 3, 4, 5. 5. So it's pentene. Where does the double bond start? On the second carbon. There is a methyl group on the third carbon. 1, 2, 3. You see, this is not a methyl group. I mean, it is a methyl group, but once we name it, it's part of that name right there. Follow me? This is not a methyl substituent. This is carbon number 1. That is a methyl substituent. So that's a 3-methyl. And because the 2 things that were the same on the molecule are on the same side of the double bond, it's cis 3-methyl 2-pentene. Now, if that sounds confusing, I would say, you know, it is. It is confusing. You know, it's not easily discernible, but think about it, all right? There's your longest chain. Once I get those 5 carbons out of the way right there, my only leftover is that. It's my methyl group. But this and this, you know, the molecule doesn't care how we're doing this stuff. It just happens to be that that is a CH3, that's a CH3. They're on the same side of the double bond. So that's a cis isomer. Okay, let's let that soak in. Let's take a 5-minute break. Okay, I think the very next slide, well, there's another example, trans 1,2-dichloro-1-butene. So this is 1-butene, but if you went through those 3 questions, that's different from that, yes. That's different from that, yes. These 2 carbons have something that's the same, the chloro groups. And where are they? They're across from each other. Trans. So there is a molecule that has another isomer. It would be the one where the chlorine is in here. That chloro is here, that would be cis. All right. So here's the next slide. Take a look at those 3. I need to make do a little quick communication here. Look at A, B, and C and decide whether you think A has is an isomer that has another a pair, B and C. did you find it, just right now?
Right now.
It was there earlier at around 1, because it was there when I came upstairs.
No, I don't.
Yeah, okay, I'm trying to find what it is.
Okay.
Eventually she'll notice. I'm so glad nobody took it. You know what? I lost my charger.
Okay, let's look at A. What do you think? Cis and trans isomers for A? I mean, does it have an isomer? Yes. Okay, it is, and you're saying it is the trans isomer? Yes. All right, because these two methyls here are across from each other. How about B? Neither. Neither, because these two things are the same, right? And once if you see either one of these carbons having two things that are the same, you've got a no answer. Once you get one no answer, they're not isomers. Doesn't have an isomer. How about this one? Cis. And it is a cis-trans situation because this is different from that, that's different from that. This is the same as that, that's the same as that. And so those are cis to each other. Now let me just take that one as a quick example there. What's the longest chain? C. Yeah, C. Longest chain? 6. So it's hexene. Yes? And where does the double bond begin? 3. And you just told me that it's cis. That's its full name. Cis 3-hexene. But if I give you that molecule and say name it, and you say, oh, it's 3-hexene, you haven't given me the full name. Oh, don't worry about that. We just did that, so forget that. Draws cis 3-chloro-2-methyl 4. Yeah, okay. Try to draw that. I'm looking at this name, trying to think how would I attack this. But let's see here. I think I would start with, okay, we've got octene. We know we're going to have 8 carbons. but the double bond is going to be on number 4. I see right at the head of the name there, cis. So I'm going to come off here. One, two, three, 4. Yeah, there we go. I'm going to put 3 carbons going off that way, and the 4th carbon I get to a double bond. The 5th carbon is my double bond, and since it says cis, I'm going to go off of this side. 1, 2, 3, 4, 5, 6, 7, 8. There's my cis 4-octene. All right, so now let's put a line here. Okay, now I need a 3-chloro. 1, 2, 3. There's a chloro group right there. There is a methyl group right there. Now, all carbons need to have 4 bonds around them. So those are going to be hydrogens. That's going to be a hydrogen. That's going to be a hydrogen. I'm going to write these hydrogens right there. There's nothing else on that double bond except those 2 hydrogens. The only other 2 things on this molecule is the chloro and the methyl. So there's going to be hydrogens there, and hydrogens there. All right, so this actually went with this. It might not always be that obvious, but it wasn't that obvious. This wasn't real obvious. But you see how we did the cis, what do we have, cis-3-hexene a minute ago? We just had cis-3-hexene. We didn't have anything else on it. So we drew it, or we didn't draw it. It was like this. That was cis-3-hexene. All right. Folks, I should probably leave. I just got a call from my doctor. She's suggesting I not be here tomorrow. And I was waiting for feedback on an x-ray, chest x-ray, and didn't get it. Was feeling a little bit better, came in here, and she's saying, well, you have pneumonia, so you really should be at home resting. So she said if there's any way someone can substitute for you, they should be doing that. I had a sub lined up for tomorrow, and I told him I was planning to come tomorrow. She said if you could at all possible get that person to teach for you, that'd be a good idea. So that's kind of where we are. So I'm trying to finish, I'm trying to drive us on the schedule, and we just may not be able to do that. So I'm trying to adjust my thinking here a little bit. Let me see where we are. I mean, if I'm 5 slides away from finishing chapter 11, we'll finish it. But I don't think that's the case.
Part 1 or part 2? Yeah, this year's like finished with part 1. I think you're just on part 2.
I'm on part 2?
No, this is part 1. It's done. Yeah.
All right, yeah. Yeah, well, part 2 is a whole bunch of slides. Okay. We're just getting ready to segue into reactions. And of course, we've got chapter 12 ahead of us. let's try to save me for another day. I'm gonna hand out 11. Let me get it in front of you. I'll tell you, it won't be due Monday, but you should be, I'll tell you what, I will collect it Monday, but not at the beginning of class. So
The
I'll-
same thing as the other one, or on the guarantee.
Yeah, and there's a certain portion of this which you can already do. So arrive here with that amount done.
Want us to have first reading?
I'll tell you in just a second, Adrian, as soon as everybody has one in their hands. Oh, hey, yeah, the other names here, that must be another class. And so let's look for name tags. Okay, so what you should be able to do so far, I think, is problem number 1. Problem number 2, I think. Yeah. Let me just make a couple comments about line and condensed formulas. And then I'll dismiss you. So, let's see, what do I need to tell you about line formulas? Okay, on line formulas, probably the best way to do this is to go back to some of these molecules that you've already, how do I go back? Yeah, it goes back to some of these molecules that we've already done here. And let's try to do a line formula. How would we do this? Yeah, what I would do here is a line, you're going to make a double bond like this. And so, and then you have 1, 2, 1, 2, 3. 1, 2, 3, 4. There you go. And you're going to have 1, 2, 3. There's your line formula. Why does this keep popping up? All right. So then you would have a methyl there, and you'd have a chloro there. There's your line diagram. Condensed. I got the line in the way here, but if you look up above there, you got this. And then you're going to have a C. I don't know why. Then you're going to have this. This. That's your condensed formula. And then you're going to have a CH2, CH2, CH3. There's your condensed formula. Anybody know how I can get it to quit asking me to sign in? Sign in. Good. I asked. All right. see what else you need to know about this here. Yeah, so if you're doing, yeah, like, well, let's just take one pentene. And so I'm going to put, I know what we'll do. Abandon that. One pentene. That's how I might draw it. Be real careful here because so often I see students putting, hydrogens, slapping 2 hydrogens on that carbon. It's not right. You do that, look what you got. 1, 2, 3, 4, 5 bonds around it. There's your structural formula. Brianna, could you turn this light back on? Onto this. This is just one pentene. And if we did a line diagram, there's one, carbon number 1, carbon number 2, 3, 4, 5. That's one pentene. I'm just giving you some examples so that you know how to do these line diagrams condensed form. Now let's do one pentine.
Was it wrong if we draw it initially? Do we have to take the geometry into consideration?
Well, I would recommend you get in the habit of drawing these alkenes, thinking of it like that, okay? Because when I say draw trans something or other, and I see it all on a line, I say, you didn't tell me, you didn't show me that you knew it was trans, okay? So I would get in the habit of thinking of that configuration. Now this one, you can come right off on a line because, remember, they are in a line. Four things are in a line around a double bond. Even if we put a carbon right here. And I'm not going to go for a few more minutes. All right, but any 4 atoms around it, all 4 of the atoms around a triple bond are in a straight line. So there, now finish off the hydrogens. How many hydrogens here? How many hydrogens here?
None, because 3 and 4.
None. 0. 3, 4. There's no hydrogens on that carbon. All right, so they really slow down, particularly when you're into something new. Slow down, analyze it. I said you need 4 bonds around any carbon. I don't care whether we're talking double, triple, whatever. I've got 1, 2, 3, 4 bonds around that carbon. And so then a line diagram. One, 2, 3, 4, 5. This is one pentene. Excuse me, one pentine. One pentine. Well, let's do this. every little thing here that you're gonna trip across in the homework, yes.
When you do the 9, how are you counting?
Well, this is 1, 2, 3, 4, 5.
So right after the 2, you don't go up. You go
No,
straight.
come straight up. And then you start bending, because you see here, there's 1, 2, 3. They're all right in a line. So by the time we get to 3, now 4 and 5 is where it's going to start bending.
Do you do the same thing with the double bond? Do you keep going straight and then?
No, the double bond would come off.
Yeah.
It's not straight. It's 120-degree angles on it. So you don't come straight out of a double bond. You bend out of the double bond, one way or another. Up or down, cis or trans, whatever. So there, you got 1, 2, 3 in a line, and then it starts bending. Doesn't that look just like that? Okay. See if I see anything else. Yeah, so you got your naming, you're trying to draw. So here you need to draw structural and line formulas for problem 1. All right, that's good enough. I'll see you Monday at 2. The doctors tell me go home and rest. So if I do that, you'll see me Monday.